For this video, we will be talking about section 10.6, 10.7, and this is actually going to be day 2. So just a couple of things that we make sure we talk about really quick. This method of factoring is going to be called the AC method, and we use this method when it's a trinomial, meaning there are 3 terms. But we also have to pay attention to the fact because day 1 was also trinomials, and we talked very briefly about this, but in those problems, a was 1, so that let us do simple factoring. But you'll notice right here on number 1, a is not 1, a is a different number. So it's going to be a trinomial, and when a does not equal 1, we use this method called the AC method. Something else I want to make sure that I point out, these steps look like they're short steps. I do not want that to fool anybody. These problems do take a little bit of work. So you'll notice right here, step 4, we're going to end that problem by factoring by grouping. And if you remember in 10.5, factoring by grouping actually does have quite a few steps to it. So, but as always, step 1, factor out the GCF if there is one. So looking at number 1, 2, 5, and 2, they don't have anything in common besides 1. I'm not going to factor out a 1 because that's not going to change anything. So similar to simple factoring, we have to find factors of a number that add up to a different number. Now on AC method, it's factors of A times C that add up to be B. So you'll see that's in step 2 right here. So find factors of A times C that have a sum of B. A in this case is 2, B is 5, and C is also 2. So remember, it's AX squared plus BX plus C. It will always be written like that. So factors of A times C would be 2 times 2, which is 4. That add up to be B, which would be 5. Now, just like before in day 1 when we were doing simple factoring, our rules for our sign do not change. So because the second sign is positive, that tells me they're going to be the same. And then the first sign tells me they are both going to be positive. So I know that my column over here for factors of 4 have to be both positive, and then they have to add up to be a positive 5. So factors of 4 would be 1 and 4, 2 and 2. If I add those up, 1 and 4 makes 5, 2 and 2 makes 4. So I know that I have to use 1 and 4. Now something else. This is all very similar to simple factoring. However, in simple factoring, we would say that our answer is x plus 1 times x plus 4, and we would move on, we'd be done. So simple factoring, simple steps, quick way to get to your answer. However, if you remember when we simple factor, the best way to check your answer is to FOIL. So I would have x squared plus 4x plus 1x plus 4. Combine your like terms, we end up with x squared plus 5x plus 4, which is not what our original problem says. So simple factoring here does not work. Our answer is not x plus 1, x plus 4, unfortunately. We are actually going to do something different with these two numbers. So finding the two numbers is the same process. However, once we find those numbers, we're going to rewrite the bx term with the factors found in step 2. It also says do not forget to include the variable. So I'm going to erase a few things here just so we're looking at a clean problem here. If I'm rewriting my bx term, that's this plus 5x. So I'm splitting that up into a positive 1x, right? That comes from this positive 1 and this positive 4, so plus 4x. If I combine those back together, that should get me to my original b value of 5x. So 1x and 4x makes 5x. Then what we're going to do is we're going to bring down c, so plus 2, and we're going to bring down a, which is 2x squared. Now, step 4 says factor by grouping. The reason that we can factor by grouping is because now there are 4 terms in that problem. So if we factor by grouping, I group the first 2, I group the last 2. If you need a refresher on this, this is from 10.5. Otherwise, once we get to this step, I'm going to kind of go a little bit quicker through these problems because we have been factoring by grouping for a while now. So between the first 2, I can factor out an x. The GCF goes out in front. When I divide by x, I'm left with 2x plus 1. And then the second parenthesis, remember we always follow that leading sign. So this is going to be a positive 2 that I'm going to factor out. And then that would leave me with a 2x plus 1 here. Remember, when we factor by grouping, I'm looking for the 2 inside parentheses to match, which they do. So 2x plus 1 is my first parenthesis. And then my second one comes from the 2 GCFs put together, so x plus 2. And that would be my final answer for number 1. Moving along, we're going to go ahead and start looking at number 2 here. So looking at number 2, factors of, again, it's factors of A times C. So in this case, it would be 2 times -3 would get me a -6 that add up to be B, which is a +1. So if we're filling out our table here, second sign is negative. That tells me they're going to be different. So one positive, one negative, and then they have to add up to be 1. So factors of -6 that add up to 1. You'll also notice on this problem, so we have a table that we can fill out, but we also have the X. So just to jog your memory here, before in day 1 it was C was the top number, but now it's going to be our A times C is our top number, so -6. And then bottom number is B, so that would be our 1 here. So then if I'm listing my factors going back to the table, +1, -6 adds up to -5, not what I'm looking for. 2 and -3 adds up to -1, which is very close to what I want it to be. But if I switch the negative, I then have -2 and +3 would get me my +1. So there's my two numbers. Or if you were doing the X's, you would be doing mental math here. So -2, +3, those are the two numbers. Regardless, however you find your numbers, remember it is not x minus 2, x plus 3. We are splitting the bx term up into a -2x and a +3x. And then I bring down C, I bring down A. Now we have 4 terms total, so we're going to factor by grouping here. So group the first two, group the last two. GCF of the first two is a +2x. When I divide that out, I'm left with, x minus 1. And then I'm factoring out, again, the leading sign here is positive, so I'm factoring out a +3 here. So then this would leave me with another x minus 1. And then again, if we've done this correctly, the two inside parentheses should match. Second parenthesis comes from the two GCFs put together, and there's our final answer. So you'll kind of notice the AC method blends some of the ideas that we've been talking about so far. The more difficult part of this section is going to be remembering what all of the steps are when you're doing each of the, so I guess not this section, but any problem that regards factoring, you're going to have to remember what the steps are for each of those problems. Looking at number 3, factors of A times C, 5 times -3 would be -15. That add up to be B, which would be -14. So then you'll notice on number 3, all we have is an X here. So remember, A times C goes on top, so -15. B goes on the bottom, so -14. Something I saw somebody do the other day, and I loved it. Second sign is negative. That tells me they're going to be different. So immediately they put a positive and a negative in their x's. I love that idea. So then factors of 15 would be 1 and 15. Somehow between that, I can get 14 out of that. So then I know that it's going to be a +1 and a -15. That would add up to be a -14. So then I would take those two numbers and I'm going to split up this bx term. So then I have a +1x minus 15x, and then again bring down a, so 5x squared, bring down c, -3, and then factor by grouping. So group the first two, group the last two. GCF of the first two would just be an x, and then left over when I divide that x out would be 5x plus 1. GCF of the last two would be a -3. Again, we're following that leading sign there, so then I have a -3 here. Left over, -15 divided by -3 is a +5x. -3 divided by -3 is a +1. My two parentheses match as they should, so 5x plus 1. And then we have x minus 3 for our final answer. Okay, moving along to the back side of our notes here, looking at 4 and 5, you'll notice that I did not give you a table, I did not give you an X. It is your choice at this point how you want to find those factors. However you choose to do so is completely up to you. I like the X's, so I'm going to continue doing the X's. My AC number would be 42. That comes from 6 times 7. My B is -23. So then the two numbers I'm going to use are -2 and -21. Again, second sign tells me they're the same. First one tells me they are both negative, so that's why it's a -2 and a -21. The whole point of finding those numbers is to split up my bx term, so -2x minus 21x, and then I'm going to bring down a, which is 6x squared, bring down c plus 7. And then from here, we're going to factor by grouping. So first two, last two. In the first two, I can factor out a GCF of 2x. When I do that, I'm left over with a 3x minus 1. And then in the second parenthesis, leading sign is negative, so I'm going to factor out a -7 from here. So -7, and then left over would be a 3x minus 1. My two parentheses match, so 3x minus 1 is the first parenthesis. Second one, again, comes from the two GCFs put together, 2x minus 7. Looking at number 5, please notice that this one has y's in it. That doesn't change anything, but when we go to write things down, we need to make sure we're using y's and not x's. That's a pretty common mistake that happens. We get so used to putting x that we forget to pay attention. If I fill my x out here, 24 times 12 would give us 288. Something to take note of, when we start to get larger numbers, I am going to start to pay attention. Again, step one is factor out a GCF. So far, we haven't had one yet, but looking at 288, kind of a big number. I'm going to double check 24, 41, and 12. Do they share anything in common? Unfortunately, they don't. So we are going to have to find factors of 288 that add up to 41. Now, the way you should be doing this is 288 divided by 1. Does it work? Yes or no? Divided by 2, does it work? Yes or no? Divide by 3, yes or no? 4, yes or no? 5, yes or no? When you do that, you eventually get to 9 and 32, which multiplies to be 288, adds up to be 41. So that's what we're going to use to split up 41. So a positive 9y and a positive 32y. And then again, bring down, not that, bring down 24y squared and bring down plus 12. Factor by grouping, group the first two and the last two. Out of the first two, I'm going to factor out a 3y. So 3y goes out in front. I'm left with an 8y plus 3. Last two, we're going to factor out a positive 4, again following that leading sign there, so plus 4. Left over would be an 8y plus 3. Two parentheses match, so there's my first answer. And then my second answer comes from the two GCFs, so 3y plus 4. We haven't mentioned this yet, and now would be a good time to do that. When you're doing these problems, please remember that you can guarantee yourself 100% on any homework, quiz, test when we're factoring if you FOIL out your answers. So for example, on number 4, if I FOIL, first would be 6x squared, outside would be minus 21x, inside would be minus 2x, last would be plus 7. If I combine my like terms, I get a negative 23x. So then if I check my answer, 6x squared minus 23x plus 7 is the original problem right there. So that is how I can guarantee that this right here is the final answer. So just to make that clear, you can still check every single answer by FOILing it back out. Looking at number 6 here, 24 times 27 is 684, if I'm not mistaken, so a very, very large number. So I'm definitely going to check for a GCF on this problem. And we do, in fact, have a GCF that we can factor out. Every single one of those has a 3 in common and an x in common, so I'm going to factor out a 3x. When I do that, I have 8x squared plus 18x plus 9 left over. So now when I go to fill my x out, please understand that you are using the two new c and a values to multiply to get 72, and the new b value of 18 when we do our x here. So we're not using the original numbers. The whole point of factoring out that 3 was to get smaller numbers. So I need factors of 72 that add to 18. That would be 6 and 12. And then remember, when we're doing this, the whole point of finding those two numbers is to split up this bx term. So I have a positive 6x, a positive 12x. I'm going to bring down my plus 9, bring down my 8x squared, and then don't forget, in every step, we're going to have to continuously bring down that 3x on the outside. Now, please understand, when we factor by grouping on this one, we are ignoring that 3x. It has nothing to do with the polynomial inside of the brackets. We are only factoring by grouping the polynomial inside of the brackets. So inside, I'm going to factor out a 2x from the first two. Left over, I have 4x plus 3, and then I'm going to factor out a positive 3 from the last two. So then that would leave me again with another 4x plus 3. And then again, don't forget, all the way out in front, we do have to have that 3x in the brackets. And then my insides match, so 4x plus 3 is my first one. Now please remember, when you go to pull the GCFs, it has to be the GCFs from the grouping process, not from the original 3x that we factored out. So the 2x plus 3 is what goes inside the second parenthesis, and then I do have to bring that final 3x down. This would end up being my final answer. Now let me be clear, 24 times 27, 684. You would eventually find factors of 684 that add up to 54. Split up up 54x, factor by grouping. Then at the end, you would have to factor out a 3x from one of your final two parentheses. So regardless, you do have to factor out that 3x to get your final answer and to make sure it is completely factored. Looking at number 7, if I draw my x here, 7 times negative 27 is negative 189. Kind of a big number, so if I look at 7, 12, and 27, I unfortunately cannot factor anything out of that, so we are going to have to figure out factors of negative 189 that add up to negative 12. If you start with this again, start with 1, divide by 1, does it work, yes or no? Divide by 2, divide by 3, by 4, by 5, by 6, by 7, by 8, and then eventually you divide by 9, and you get the magic two numbers of 9 and negative 21 that add up to negative 12. So then again, splitting this up, process has been the same this entire time so far. So splitting up that bx term with the two new numbers that we found, plus 9x minus 21x, bring down a and c, and then we're factoring by grouping here. So grouping the first two and the last two. The first two only have an x in common, so then I have 7x plus 9 left over. And then the last two, leading sign is negative, so I'm going to factor out a negative 3 here. So minus 3, and then left over would be a 7x plus 9. Our two parentheses match, so 7x plus 9. And then after that, my two GCFs put together would be x minus 3. And that would be our final answer. This is it for the first day of notes. So if you were absent for just day 1, stop here. If you were absent for both days, go ahead and keep watching here. 8, 9, and 10 were the last ones that we did on day 2. So really quick, we have a hint. What do 8, 9, and 10 all have in common? Something I do want to make sure I make crystal clear right now. Looking at number 9, it only has 2 terms, but just remember this is the same thing as 25y squared plus 0y. It's missing that bx term minus 64. So all of these are very, very similar to each other. They all can still be done by the AC method. So the method that we were just doing this entire notes page so far, still totally doable. So if what I'm about to teach you doesn't make sense, that's okay. Just do the AC method. Totally fine. 4 times 81, you get a fairly large number, but it's doable. 25 times 64, you definitely get a large number, but it is still totally doable to find two factors of 1600 that add up to be negative 1600 that add up to be 0. And then on number 10, actually, a is 1, so that would actually be simple factoring, which we'll talk about all of this. However, I just want to make it crystal clear, we're about to do something called special cases. What I need to make sure I make clear, if special cases doesn't make sense, that's okay. Just do the AC method, okay? Now, some of you are going to love this method because it is an extreme shortcut to what we've been doing so far. So 8, 9, and 10 all have the fact that, let's go with this light orange, A and C for all of these problems. This is a 1 here, so I'm circling the 1 and the 9. So 4, 81, 25, 64, 1, and 9. Every single one of those values is a perfect square. So A and C are perfect squares. I'm running out of room here. So since A and C are perfect squares, again, like I said, that is what makes these a special case. If it's a special case, we have an extreme shortcut that we can use here. So I know eventually I have to factor these, right? We're trying to break it down into 2 parentheses. In order to get 4x squared, what times what makes 4x squared? Well, if I take the square root of that, that would be 2x. 2x times 2x would be 4x squared. So in my parentheses, I know that my first 2 terms in each of the parentheses has to be 2x. Then the square root of 81, aka what times what makes 81, is 9. So I know that my last 2 terms have to be 9 and 9. Now, the sign rule, again like before, still is the same. Second sign tells me that they're going to be the same. First sign tells me that they are both negative. That's my final answer. So special cases, take the square root of A, square root of C, put them in both parentheses, put your signs in place, problem's done. Now, one thing we do need to make sure, especially with these special cases, is sometimes it doesn't work. So what I mean by that, we do have to check our answer. We're going to FOIL here, but we're going to do like a loose version of FOIL. We already talked about how 2x times 2x is 4x squared. I know that's going to check out. We already talked about how 9 and 9 is 81. I know that's going to check out. I need to confirm that what I get when I multiply the the outside and the inside values, I get negative 36x. So outside would give me negative 18x. Inside would give me negative 18x. If I combine those together, I get negative 36x, which checks out. That is what that middle term is. So I know this is my final answer. Very similar to number 9 here. If I take the square root of a and the square root of c, please understand we are not taking the square root of negative 64. If you remember from chapter 8, we cannot take the square root of a negative number. It's actually going to be an imaginary number, but for us in this class, we just said it was no solution. Eventually there will be a solution. However, we are not taking the square root of negative 64. I'm going to use that negative later to help me put my signs in place. So I'm just taking the square root of 64, not negative 64. Just want to make that clear. So square root of 25y squared is just 5y. Square root of 64 is 8. So that in my two parentheses, I have 5y and 8 and 5y and 8. And then if I put my signs in place, if you pay attention here, this negative is actually the second sign, so that tells me my signs are going to be different. So I'm going to put a plus and a minus here. And then again, like I said, we do have to check our answer. So if I'm thinking this is the right answer, and then I go to check myself, again, I know first and last are going to give me 25y squared and 64. We've already talked about that. But if I do my outside, I would get negative 40y. And if I do my inside, I get a positive 40y. If I add both of those up, it gives me a 0y. They would cancel out, which is exactly what I want to happen in that problem. So I know that checks out. This does end up being my final answer. Now on number 10, again, 1 and 9 are perfect squares. I know some of us kind of forget about the 1 sometimes, but 1x squared or just x squared is a perfect square. So if I take the square root of x squared, I get an x. If I take the square root of just 9, I get 3. So then if I put x and 3, and then if I put my signs in place, second sign tells me that they're going to be different. So I know that it's a plus and a minus. If I sit here and I check this answer though, this is going to be one of those times where we do have to make sure we pay attention. If I do my outside, I get negative 3x, and my inside, I get positive 3x. If I add those up, I get 0x, which is not what this middle term is right here. So unfortunately, special cases is not going to work for this problem. So that is why it's really important you check your answer. So if it's not going to work, I need to think about what method of factoring I need to use here. Remember, we have multiple methods that we can use. So starting from the beginning, we learn how to factor by grouping. Well, I can't factor this one by grouping because there's not 4 terms. Then we learned simple factoring. If you remember, simple factoring is when it's a trinomial and a is 1. Well, in this case, a is 1 and it's a trinomial, so I know that I'm going to do simple factoring here. Now remember what we talked about earlier. Simple factoring is just means that the steps are simple. Very quick to get to your final answer here. So if you remember the steps, look for a GCF, there isn't one. Draw 2 sets of parentheses. Split up your first term, which is x squared, so we split that up as x and x. Put our signs in place. We already talked about how they're different. That rule does not change, so I know that I have 1 plus 1 minus. And then factors of c that add up to b, which would be factors of negative 9 that add up to negative 8. Our two numbers here would be a 1 and a negative 9. So then x plus 1, x minus 9, there's my answer. So if simple factoring doesn't work, you just have to go back to one of the 2 original methods that we learned. So that is it for these notes. I just want to make it clear one more time. If special cases doesn't make sense to you, just factor it with the AC method or simple factoring, whichever one applies. So on 8 and 9, you'd have to do the AC method because A is not 1, whereas 10, you do simple factoring because A is 1. So again, special cases, totally not a big deal if it doesn't make sense. But if it does make sense, it's just a major shortcut that you can use to get to your final answer. So that is it for these notes.